Hey guys, it's Ranj. Today I'm going to do my first video on mass and balance. I online tutor mass and balance and general navigation. If you're interested, take a look at my website, ATPLapproach.com. I have helped a fair few people pass their exams with quite exceptional results. So yeah, going to be doing videos on mass and balance as well. Not in any particular order, just taking a look at questions from the ATPL question bank and showing you how to better understand/solve them. This one here is a question which has been spotted in multiple real exams, and more specifically from the UK CAA last week. It has a lot of debate, with a huge amount of comments due to people getting confused and talking about which method is the best. There are multiple methods to solve this question, going from quicker methods which are a bit more case specific and cannot be used for all of these types of questions, to methods which take a bit longer but work for pretty much every mass, arm, moment question in mass and balance. I will show a few methods and we'll start with the more difficult one. The idea is, if you do not completely understand the method I'm using, to carry on watching until you find the one that you do. Stick to the end of the video to know the method that I used for when I took my exams. So here is the question. An aircraft has its datum at the nose. The front seats are 65 inches aft of the datum. The passenger seats are 105 inches aft. And the separate baggage compartment is 145 inches aft. The aft limit is 147 inches aft. I'm saying aft a lot of times here. The current mass is 2,750 pounds. And it says 3 passengers are in the rear seats with the baggage compartment full. And they all want to sit together so the front seat is empty. Okay, kind of picky passengers. However, the pilot is very light, and in this situation, the centre of gravity of the aircraft is 3 inches behind the aft limit. Seems like we're going to have to sort that out. Ignoring maximum mass limits, how much extra ballast must be secured in the front seat to bring the C of G to the authorised limit? What? So much information. It takes a couple of minutes to read the question, and well, for mass and balance you don't really have that time, so they really like throwing these things your way to sort of put the time pressure there. So what we need to do is get the bits of information we need. We know it's a moving C of G type question, and we want to find the amount of mass that needs to be added to bring the aircraft within the limits. With this, we should draw a diagram to get all the key information in one place. The simple way I draw is to draw a line. Do a nice big diagram here, and on this line the right end is going to be the front end of the aircraft and the left end will be the aft. We're told that the datum is at the nose, so I'll do a dashed line here representing the datum. We are then told a few positions. I'll put them on the diagram. So 65 inches will be the front seats. 105 inches are the passenger seats, so I'll call that PS. And the baggage compartment is 145 inches, so I'll call that BC. And I'll put on those measurements. So we've got 65 here, 105 there, and 145 there, all in inches. The aft limit is 147. I'll call that AL, so it's just 2 more inches away from BC. Let's just put that here. There's the 2 inches. The current mass is 2,750 pounds. But we're given all this sort of nonsense information before we're actually told the centre of gravity. And that is 3 inches behind the aft limit. So we're just going to go 3 inches from there to put where the centre of gravity is. Going to draw it like that. Sometimes it's got, that sort of coloured in. You don't really need to do this. I'm just doing that for show. And yeah, putting in the distance there. Okay, so now we have the diagram done, Let's start with this quick method, which is governed by the following formula. The change in mass, that triangle being a delta sign, over the original mass, which I'll call m1, is equal to the change in center of gravity divided by the distance between the new center of gravity position, which I'll call cg2, and the position where we are adding the mass. I'll just call that p. This method only works when you're adding or subtracting mass from the aircraft. Stick around if you want to see the method which works for everything. So now I'll fill in the values. The change in mass will be the ballast that we are putting on the front seat, which is the unknown that we're trying to find. I'll call that B. And we divide that by the original mass, which is 2,750 pounds. And we set that equal to the change in center of gravity. We want to add the amount of ballast to the front seats so that we bring the center of gravity over here to the authorized limit. That delta center of gravity, or that change in center of gravity, is given here. There's the old center of gravity position, and that's where we want it to be on the new authorized limit. So that's 3 inches. We do that divided by the new center of gravity mass position, take away the distance in which we're putting the ballast on. So the new center of gravity mass position is this authorized limit. That measured from the datum is 145 plus 2, which is 147. And then we subtract the position where we're putting the ballast, which is Fs, which is at 65 inches. Cool, so now I'm going to simplify this. Well, we can go straight to the answer here really by just multiplying both sides of the equation by 2,750. And if we do that, what we get is 100.6 recurring. And the closest answer to this over here is D. See, that's a short and quick method, but this cannot be used for all sorts of questions, and you might not be familiar with this type of method. If that's the case, that's absolutely fine, because if you use this method in the wrong context, such as for a repositioning mass question, you might get an answer which the aviation authorities have purposely put in there as the wrong answer, which could catch you out. Before we get into the next method, I want to show you an ad from my sponsor. Joking. I don't have a sponsor. This is all self-funded, and what helps me produce these videos are funds made from online course sales and also donations. I wish to make these videos more often, and if you'd like to see this, please consider donating using the link in the description or taking a look at my online course here. Okay, now on to the next method. This is where we use the formula the new moment, which I'll call mom2, is equal to the old moment, which I'll call mom1, plus the change in moment, which I'll call change mom. This formula here we can use for repositioning mass as well as adding or subtracting mass. We know that a moment in this context will be the mass multiplied by the distance. Our new moment is going to be our old mass plus our ballast mass B. Let me just write that here. So 2,750 plus B multiplied by our new center of gravity position, which will be on the aft limit, which we can see from here is 145 plus 2, which gives us 147. And we're going to set that equal to our old moment, which is the old mass, which is 2,750, multiplied by the old center of gravity position, which is this 145 plus the 2 plus the 3, which gives us 150. And then we'll add our change in moment, which is the ballast B multiplied by the distance it's acting from the datum, which is at the front seats, which is 65 inches. Cool, so now we've got an equation here which we can solve. So now we're going to expand these brackets, which is going to be the 147 times the 2,750. That is 404,250. And then we do the 147 times b, which is 147b. And that is going to be equal to 2,750 multiplied by 150. That gives us 412,500 plus 65b. Then we rearrange to get b on one side and all the numbers on the other side. So I'm going to subtract 65b from both sides. That gives us 82b is equal to 8,250. We then divide both sides by 82, and that gives us our £101. If this method is difficult to understand, then we can try to visualize it in a mass arm moment table. So I'll draw one out for you guys. Just going to write M there for mass, A for arm, and then MOM for moment. The key rules for this table is that when we go down the columns, we add the values. We don't do this for the arm column, however. And when we go across from left to right, we multiply the values, because the product of mass and arm is the moment. If we go from right to left, we sort of do, one divided by one of the others to get the other one. So let's fill in the values for this mass arm moment table. Initially, we're going to start with the original configuration, which is our original mass of 2,750 pounds multiplied by the original center of gravity position, which is this 145 plus the 3 and the 2. So that's 150. And that multiplied gives us 412,500. We then want to add on our change in moment. So the way we get that is we put on our mass. Well, we don't know that mass, that is our unknown. So we call that our ballast, which is B. We know the position it's going to be acting, because this will be the front seats, and that's at 65 inches. And then those two multiplied together will just give us 65B. Cool, so that's our original configuration plus the ballast, and that will give us our final configuration, the configuration that we want. So we're going to add down the columns as mentioned before. So this will give us 2,750 plus B. We can't add down the arms column, but we can on the moment. So we get 412,500 plus 65B. And now we've got one value blank, which is this value here. This is where we want the arm, the center of gravity, to be in the final configuration. Well, the whole point of adding the ballast here was to put it in a specific place, which was on the aft limit. And that was 145 plus that 2, which is 147. So what that gives us is now another equation. As I said, the moment is the product of the mass and the arm. So we can set an equation, which is where this is equal to this multiplied by this. And if I write that out, that actually gives me the same thing I had back over here. So when you put that equal to that and you go ahead and find B, it will give you the same answer, which is £101 up there. Okay, so those were sort of three methods I showed you with this question. And the ones that I used for my exams, which actually I think was a little bit of a mistake, because with the mass and balance exam, I found out, well, when I was doing it, it was very time pressured. And what I did was sort of went through the method of trying to remember the least amount as possible and essentially learn the method which would work for all types of questions. So what I did for pretty much all mass arm moment questions was draw this table out here. And yeah, it might work for every single question, but it does take a bit of time. So I think a combination of The second method, which was just this in equation form, will be slightly quicker. And then you can actually resort to this mass on moment table if maybe in the exam having a bit of a brain freeze and you're not really sure what to do. It's sort of another method to fall back on. Or maybe perhaps when you get to the end of your maths and balance exam, you might have extra time. So if you know multiple methods, you can then go ahead and recheck your answers so that, you're 100% sure you got that question right. I remember with the maths and balance exam that there weren't that many questions. That means that each specific question had quite a large effect on the percentage mark that you would get. So going back and checking them if you do have time would be very, very advantageous. Thanks for watching my video. If you want to see more things like this, please like and share the video with your buddies and the communities you are within. I want to spend more time doing things like this so I can release more videos and improve the quality of my content, but can only do that with your help. Thanks again and see you soon.